August 15, 1977, 10:16 p.m. In the quiet fields of Ohio, a machine is listening. It is an enormous, unmoving metal ear, the size of 3 football fields, pointed at the silent, starry void. This is the Big Ear Radio Telescope. It is not, on this night, being operated by a famous astronomer or a government agency. It is a volunteer project, patiently scanning the cosmos, hunting for a signal that no one truly believes will ever come. A stream of data flows from the telescope, a continuous printout of numbers and letters, a quiet record of the background hiss of the universe. It is a language of mundane static. To 1, 2, but then, for 72 seconds, the machine hears something impossible. The numbers explode. 6, E, Q, U, J, 5. It is a shout. A sudden, coherent, deafeningly loud, and perfectly artificial-looking blast of energy from deep space. And then, as suddenly as it began, it is gone. The numbers drop back to 1. 2. The static returns. The universe is silent again. The printout paper scrolls on, burying the anomaly in a tomb of meaningless data. The event is so brief, so intense, that no one on Earth even knows it happened. The machine heard a whisper that sounded like a scream, and then the night went on. A few days later, a 37-year-old volunteer astronomer named Jerry Ehman sits down to his routine task, reviewing the data printouts from the past week. His job is a search for needles in a cosmic haystack, and he expects to find nothing but hay. He unspools the massive fanfold paper, his eyes scanning the endless columns of numbers, a mundane and repetitive chore. His eyes move across the page. 1s and 2s, more 1s, then he stops. His blood runs cold. He sees the sequence, 6 extra 5. He doesn't understand it. It's not noise. It's not an error. It's a perfect bell-curve spike, exactly what a radio signal from a distant fixed-point source should look like as the telescope's beam sweeps across it. It is the textbook signature of an intelligent, extraterrestrial beacon. In a moment of stunned, visceral reaction, a feeling of profound, heart-stopping discovery, Ehman grabs a red pen. He circles the entire impossible sequence, and in the margin he writes one single human word. Wow! That one word would echo for decades. It would become the name for the single most tantalizing and most frustrating mystery in the history of astronomy. The wow signal was not just another anomaly. It was, and remains, the single strongest candidate for an extraterrestrial communication ever recorded. For 72 seconds, an unknown transmitter, located somewhere in the constellation Sagittarius, broadcast a signal so powerful it dwarfed the natural background noise of the galaxy. It was a signal that, by all appearances, wanted to be found. And then, it vanished. It has never been heard again. For nearly 50 years, the world's most powerful telescopes have returned to that same patch of sky, listening. They have heard nothing. It is a cosmic hello with no return address. A message in a bottle that was seen for a moment and then lost in the tide. The question is not just what it was, but how it could be. How could a signal so impossibly strong, so perfectly tuned, appear for 72 seconds and then never again? To understand the mystery, we must first understand the machine that heard it and what it was built to find. The story of the WOW signal does not begin in 1977. It begins decades earlier in the mind of a young physicist named Philip Morrison and with a simple, revolutionary question. In 1959, Morrison, along with his colleague Giuseppe Cocconi, published a paper in the journal Nature. They asked, if an alien civilization wanted to contact another, how would they do it? They couldn't use lasers, not with 1950s technology. They would use radio. But the radio spectrum is vast, 1 billion channels of static. How would you choose the right frequency to listen on? Where would you tune the dial? Morrison and Cocconi proposed a brilliant, poetic answer. They would broadcast on a frequency that was cosmically obvious, a universal landmark that any intelligent species, no matter their biology, would recognize. That frequency is 1420 megahertz. It is the natural, whispering frequency emitted by neutral hydrogen atoms. Hydrogen is the most common element in the entire universe. It is the building block of stars, of galaxies, of life itself. This hydrogen line, as it's called, is a quiet, protected band in the radio spectrum, a channel largely free of cosmic noise. It is the perfect interstellar watering hole, a place where different civilizations might logically gather to talk. If anyone was going to send a message, they would send it there. This paper was the birth of the modern search for extraterrestrial intelligence, or SETI. Just a few years later, Ohio State University, inspired by this idea, built its own SETI machine. But they had little funding. They couldn't build a sleek, steerable dish like the ones at NASA, so they built a brute force instrument, the Big Ear. It was a marvel of low-cost, high-power engineering. It had two massive, fixed metal fences. One, a flat reflector, and the other, a curved, focusing reflector. It was essentially a giant, immovable mirror. It could not be aimed. It could not be steered. It simply stared, unblinking, at one patch of the sky. To scan the cosmos, it used the most powerful motor it had, the rotation of the Earth itself. As the planet turned, the telescope's narrow beam would sweep across the sky like a searchlight, day after day, night after night. Its primary mission, which began in 1973, was to patiently map the entire sky for radio sources. This is where Jerry Ehman comes in. The project, starved for cash, was run by volunteers. Ehman was a professor, but he gave his time freely to the Big Ear, helping to maintain its complex computer systems. His part-time job was to be the first human filter, to scan the miles of paper printouts for anything that looked unusual. To understand his shock, you have to understand the code on that paper. The computer measured the signal's intensity every 12 seconds. To save ink and paper, it didn't print a long number. It used a simple, single-digit code. A 0 meant no signal. 1 meant a faint background hiss. 2 meant slightly stronger, and so on, up to 9. But what if the signal was stronger than 9? The system was designed for this. If the signal's intensity hit 10, the computer would print the letter A. 11, it would print B. 12, C. All the way up to Z, which represented a signal 35 times stronger than the background noise of the galaxy. It was a scale of intensity that the telescope's designers almost never expected to use. Now, look at the code Ehman circled. 6 equals 5. It starts at 6, faint but clear. 12 seconds later, it's E, an intensity of 14. 12 seconds later, Q, an intensity of 26. Then U, a staggering intensity of 30. 30 times stronger than the background noise. Then it falls, J, 19, 5, and then it's gone, back to 1. It was a perfect symmetrical bell-shaped curve. It got louder, peaked, and got quieter. This shape was the smoking gun. The Big Ear had 2 receivers. A signal from space would enter the first receiver, then, 3 minutes later, the second. But the wow signal only appeared in one, and the telescope's beam only took 72 seconds to sweep across a single point. The signal's 72-second duration, its perfect rise and fall bell curve, was an exact match for the telescope's antenna pattern. It meant the signal was not from Earth. It was from a fixed, pinpoint source in deep space. And there was something else. The frequency. The Big Ear was listening on 50 different channels, all centered around the 1,420 megahertz hydrogen line. The wow signal was not on all 50. It was a laser, not a floodlight. It was confined to one single, 10 kilohertz wide channel. It was a narrow-band signal, the very definition of an artificial transmission. Natural cosmic sources, like pulsars or quasars, broadcast noise over a huge range of frequencies. They are loud, but they are messy. This was clean. This was precise. This was, by all metrics, intelligent. The team at Ohio State was electrified, but cautious. This was a discovery that would change human history. It could not be a mistake. The director of the observatory, John Krause, and his colleague Bob Dixon immediately launched an investigation. The mystery box was open. The first and most obvious suspect was the telescope itself. Was it just a bug? A computer glitch? A failing piece of 1970s hardware? Ehman and the team scoured the computer logs. They checked the hardware. The system was running perfectly. There were no known bugs that could produce a signal that looked like this. The data was clean. The computer had simply and faithfully recorded what the antenna had heard. The glitch theory was ruled out. It was not the machine. The next suspect, Earth. Was it contamination? A red herring? The signal was powerful. Could it have been a stray broadcast from a high-altitude airplane? A secret military satellite? Or even, as some suggested, a reflected television broadcast from the other side of the planet? This too was quickly dismissed. The 1420 MHz hydrogen line is a sacred, protected band. By international agreement, all terrestrial and space-based transmissions are forbidden in this frequency range, precisely so it can be used for radio astronomy. No plane, no satellite, no TV station should have been broadcasting on that channel. To do so would be a massive, illegal violation. But even if someone had, it wouldn't look like the WOW signal. A signal from a plane or an orbiting satellite would be moving. It would have a characteristic drift in its frequency, a Doppler shift. The WOW signal was astonishingly stable. It was parked on its frequency. And more importantly, the 72-second bell curve was a perfect match for the Earth's rotation sweeping past a fixed celestial source. A moving satellite would have a different, faster, and more erratic signature. This was not a satellite. And what about a reflection? Could a stray, earthly signal have bounced off a piece of space debris, a forgotten satellite, or even the moon, and back into the telescope's beam? The team ran the calculations. For a reflected signal to be that strong, that loud, the original originating broadcast would have to have been impossibly, apocalyptically powerful. No such transmitter existed. And again, it would not have produced that perfect 72-second bell curve. It was not from Earth. The team was left with a terrifying, exhilarating conclusion. The signal was real. It was not a glitch. It was not from Earth. It was an artificial, narrow-band beacon, broadcast at the most logical frequency in the universe, from a fixed point in deep space. They had done it. SETI had succeeded. They had found a signal. Now they had to do one thing: find it again. This is where the mystery deepens and the frustration begins. John Krause and Bob Dixon pointed the big ear back to that exact patch of sky. They scanned it and scanned it and scanned it. For the next month, they listened. They heard nothing, only static. The 72-second shout had been replaced by an endless, deafening silence. The team had to pinpoint where it came from. The big ear had 2 receivers, and the signal only appeared in one. This allowed them to narrow its origin to one of 2 boxes in the sky. Both were in the constellation Sagittarius. But this was not a small patch of sky. It's a dense, complex region lying in the direction of the galactic center, a field rich with stars and with possibilities. In the following years, and then decades, the WOW signal became a legend, a call to arms for SETI researchers. The biggest, most powerful telescopes on Earth were pointed at those 2 boxes in Sagittarius. In 1987, and again in 1989, the Meta project at Harvard, funded by Steven Spielberg, scanned the area. Nothing. In 1995, Project Phoenix, using a massive telescope in Australia, listened for 200 hours. Nothing. The Allen Telescope Array, the Very Large Array, the Green Bank Telescope. All of them have, at some point, pointed at that spot. They have never heard a repeat. Not once. This is the central paradox of the WOW signal. How can a signal be so strong it is detected by a modest 1970s-era telescope and yet be completely invisible to our vastly superior, modern technology? It makes no sense. If it was a genuine repeating beacon, we should have found it. The fact that we haven't has opened the door to a new wave of skepticism and a search for a new, more mundane red herring. For 40 years, the signal remained an anomaly, an unknown. But in 2017, a new controversial theory emerged. A researcher proposed a new suspect, not an alien civilization, not a secret satellite, but something that was, at the time, completely unknown to science and which just so happened to be passing through that exact region of space on that exact night. A comet. The theory was that a comet, or perhaps 2, not even discovered yet, were releasing a massive cloud of neutral hydrogen gas as they passed near the sun. This gas cloud, excited by solar radiation, could, in theory, glow at the 1420 MHz frequency. The Big Ear, passing over this transient cloud, would have recorded it as a wow signal. It was a natural phenomenon, masquerading as an intelligent one. This comet theory was a bombshell. It seemed to solve everything. It explained why the signal was strong. The cloud was vast. It explained why it was on the hydrogen line. It was hydrogen. And most importantly, it explained why it was never seen again. The comets had moved on. They were no longer in the telescope's beam. It was a perfect, neat, and entirely natural explanation. The mystery, it seemed, was solved. But was it? Almost as soon as the theory was published, the original WOW team, including Jerry Ehman, fired back. They methodically dismantled the comet theory. First, they argued, a comet's gas cloud is enormous, diffuse, and spread out. It would not create the sharp 72-second bell curve of a pinpoint source. It would have looked smeared, messy, and would have lasted for many minutes, not 72 seconds. Second, and more damning, a comet cloud would be faint. For it to be as loud as the WOW signal, the comet would have to be releasing an amount of hydrogen so impossibly, physically vast that it defied all known models. It would have to be an event far more spectacular and anomalous than the signal itself. And third, the Big Ear had two receivers. A signal from a diffuse cloud which was moving should have been seen by both. It was only seen by one. The comet theory, which had seemed so elegant, collapsed under scrutiny. The WOW signal was not a comet. It was not a glitch. It was not a satellite. It was not a reflection. Every single red herring, every mundane explanation had been investigated and, one by one, had been ruled out. The mystery box, which had seemed to be closing, was suddenly and frustratingly wide open once more. The signal was, once again, an unknown. This has left astronomers with a puzzle that has haunted the field for nearly half a century. We are left with a ghost. A signal that ticks every single box for an intelligent, extraterrestrial message, but has offered no proof, no repeat, and no source. The investigation, having exhausted all earthly and natural explanations, was forced to turn back to the most incredible and most terrifying possibility, that it was exactly what it looked like. But if it was alien, the paradox only gets deeper. Why has it never been heard again? This single, agonizing question has spawned a dozen new theories, each attempting to explain the silence. The first, and most humbling theory, is that we are simply incapable of finding it. The WOW signal's origin was traced to a patch of sky in the constellation Sagittarius. This is, by sheer cosmic bad luck, one of the worst possible places to search. Sagittarius lies in the direction of the center of our Milky Way galaxy. When we look there, we are not looking into a quiet, dark void. We are looking into the downtown core of a galactic metropolis. The region is a blinding, chaotic storm of radio noise. It is packed with hundreds of billions of stars, swirling gas clouds, exploding supernovas, and the radiation spewing supermassive black hole at our galaxy's heart. Trying to find one, faint, repeating beacon in that mess is like trying to hear a single, whispered conversation in the middle of a stadium during a rock concert. The background noise is overwhelming. The modest Big Ear telescope in 1977 just happened to be listening in a moment of quiet on a channel that, for 72 seconds, was perfectly, miraculously clear. This search for a needle in a star stack was the primary challenge for decades. Astronomers pointed their telescopes at the box of sky, hoping to get lucky. But they were listening blind. There were just one of 100 billion stars in the galaxy. But which star? Without a target, the search was a shot in the dark. This frustrating search continued for years. And then, in 1998, the story takes a tragic, irreversible turn. The Big Ear telescope, the very instrument that made the discovery, was destroyed. The land it sat on had become valuable. Ohio Wesleyan University sold the plot to a developer. The massive, 110-meter-wide metal ear, a monument to human curiosity, was torn down, scrapped, and replaced. Today, the site where humanity first heard a potential call from the cosmos, is a golf course. The ear that heard the signal is now a putting green. This act of scientific sacrilege meant we could never go back. We could never use the same instrument in the same way to try and recapture the magic. The original detective was dead. The case had gone cold. For decades, that's where the story stalled. The signal was a perfect, unsolved mystery. A historical artifact. But in the 2020s, a new generation of tools gave us a new way to investigate. The problem wasn't just our ears, it was our eyes. We had been listening for a shout in a crowd, but we had no idea what the shouter looked like. A new astronomical tool had come online, the Gaia Space Telescope. Gaia is not a radio telescope. It is a mapper. Its mission is to create the most precise, three-dimensional map of the Milky Way ever attempted. It is charting the exact position, brightness, and composition of over 1 billion stars. In 2022, an amateur astronomer named Alberto Caballero, a citizen scientist, much like the volunteer Jerry Ehman, had a brilliant idea. He realized he could use this new public database to cross-reference the old mystery. He would not search for a signal. He would search for a signaler. His logic was simple. What kind of civilization would we expect to be sending a powerful narrowband signal on the hydrogen line? The only one we know of is us. So, he decided to search the original, wow, signal box for a star just like our own, a G-type, sun-like star. A star that could, in theory, host a planet like Earth, which could, in turn, host a civilization like ours. He dove into the Gaia data, filtering the hundreds of thousands of stars in that patch of sky. He filtered by star type, looking only for G-type and K-type stars, which are considered the most stable and likely to host life. He filtered by temperature. He filtered by luminosity. The database, which began with millions of possibilities, narrowed, and narrowed, and narrowed, and then it returned a single stunning candidate. Out of all the stars in that region, one was a near-perfect solar twin, a star designated 2-mass 19,281,982 to 2,640,123. It is a G-type star, 1,800 light-years away. It has almost the exact same temperature, the same radius, and the same luminosity as our Sun. It is, for all intents and purposes, a mirror image of our own solar system's parent star, located precisely where the wow signal came from. This was the aha moment the investigation had been missing for 45 years. This was not a random anomaly. This was not a comet. This was a signal that pointed directly to a star system that is, by all known metrics, the single most likely place to find a civilization like our own. We finally had a suspect. We had a return address. This changed everything. The search was no longer blind. Astronomers could now focus all their efforts, all their most powerful instruments, not on a vague empty box, but on this one single, tantalizing point of light. But this discovery, while solving one mystery, created another. The star is 1,800 light-years away. That is an immense distance. For the big ear, a relatively primitive telescope, to have heard anything from that far away, the signal would have to have been broadcast with a staggering amount of power. Calculations were run. The transmitter on the other end would need to be a 2.2 gigawatt behemoth. That is more powerful than the largest radio transmitter on Earth. It would be a machine that dwarfs our own technological capabilities. This was not a simple hello. This was a broadcast of almost unimaginable power, a beacon designed to be heard across a vast sector of the galaxy. This new fact led to a new and very plausible theory. The lighthouse hypothesis. What if the signal is from that star, but it's not a continuous broadcast? What if the alien civilization built a massive beacon and it is sweeping the galaxy in a slow, focused beam, like a cosmic lighthouse, looking for new partners? That beam, traveling for 1,800 years, happened to sweep across our solar system. For a brief, 72-second window on August 15, 1977, the beam illuminated the Earth. The Big Ear telescope was pointed at the right place, and we caught it. And then, the beam moved on. It is now pointing at another star system, millions of miles away. It will not be back for thousands, perhaps tens of thousands, of years. This would explain everything. It explains the signal's strength. It was a focused, high-energy beam. It explains why it was on the hydrogen line. It was a deliberate hello. And it explains, in the most profound and frustrating way, why we have never heard it again. We missed it. We had one chance. We heard it. And now it is gone forever. But another, equally compelling theory has emerged, one that gives a faint glimmer of hope. This theory suggests the signal is still on, that it is a continuous broadcast, and we are just not lucky enough to hear it. This is the interstellar scintillation theory. We think of deep space as empty, but it is not. It is filled with thin, turbulent clouds of plasma and gas. As a radio signal travels for 1,800 light-years, it passes through this material. This plasma does not stop the signal, but it bends it. It acts like a cosmic imperfect lens. This phenomenon is called scintillation. It is the exact same reason stars twinkle. You are not seeing the star get brighter and dimmer. You are seeing the Earth's atmosphere bend its light, focusing and defocusing it. On a cosmic scale, the same thing is happening to the WOW signal. For 99.9% of the time, this interstellar plasma is bending the signal, defocusing it, and smearing it out, making it so weak that even our most powerful telescopes cannot distinguish it from the background noise of the galaxy. But on August 15, 1977, a chance, perfect alignment occurred. The swirling plasma clouds, for just a few moments, aligned in the perfect way to form a massive gravitational lens, a cosmic magnifying glass. This lens focused the faint, distant signal, amplifying it, perhaps by a factor of 1,000, and aimed it directly at Earth. For 72 seconds, this cosmic lens twinkled the signal to an incredible brightness. The big ear, in that moment, was staring right at it. It was a 1-in-a-million-year alignment, a perfect, fleeting moment of cosmic luck. This scintillation theory is, in many ways, the most tantalizing. It means the signal is still there. It is always there, a faint, continuous whisper, waiting for another chance alignment of the cosmos, or perhaps a telescope powerful enough to hear it without the magnifying glass. It means the message is not lost. We are just, at this moment, deaf to it. This theory separates the WOW signal from all other SETI searches. It suggests that a positive detection isn't just about pointing your telescope in the right direction. It's about pointing it at the right direction, at the right time, during a cosmic focusing event that might last only minutes and might only happen once every 50 years. It makes the search for alien intelligence not just a search in space, but a search in time. But this too is a frustrating answer, because it's a theory that is, for now, almost impossible to prove. We are left with two equally fantastic possibilities. Either an alien civilization, 1,800 light-years away, aimed a gigawatt-scale lighthouse at us, which we saw for 72 seconds before it swept past, or they have a continuous beacon that was, by sheer dumb luck, cosmically magnified for 72 seconds. In either case, the silence we hear today is an illusion. This has changed the very nature of the search. In the 20th century, SETI was a patient, passive act of listening. Today, it is an active forensic investigation. The WOW signal was an analog anomaly found on paper. Now, the search is digital. Modern projects like the Breakthrough Listen Initiative are no longer just looking for a loud signal. They are using supercomputers to sift through petabytes of data, searching for signals that are not just loud, but smart. They are looking for the telltale signs of information, complex modulation, post signals, or data-rich, compressed transmissions. They are not just listening for a hello, they are listening for a conversation. And this brings up a new, unsettling possibility. What if we are looking for the wrong kind of signal? The WOW signal was just a carrier wave. It was a pure, unmodulated tone. It was the equivalent of a dial tone. It carried no information, no message, no 6EQH5. That code was our description of its intensity, not its content. This has led to a third, more militaristic theory, the sniper shot, or the beacon test. What if the signal wasn't a hello at all? What if it wasn't a lighthouse meant to be seen by all? What if it was a ping? Imagine a civilization wanting to know if any of its neighbors are listening. They don't want to broadcast a continuous, powerful beacon. It's a massive waste of energy, and it reveals their position to any potential rivals. Instead, they do exactly what a nuclear submarine does. They send out one single, incredibly powerful, focused ping. Then they go silent and listen. They listen for an echo. They listen for a reply. This ping would be designed to get anyone's attention, a blast so powerful it couldn't be ignored. It would last for just a few moments, and then it would be gone. The civilization would then spend the next century or the next millennium just listening, using their own, far more sensitive telescopes to see if anyone at that target star system pings back. In this scenario, the wow signal was not an invitation to talk. It was a test. It was an interrogation. Are you there? And our response for the last 50 years has been total, unbroken silence. But there is an even simpler, less deliberate theory. One that is just as plausible. The accidental leakage theory. We, as a civilization, are noisy. We leak radio signals into space from our televisions, our radios, and most powerfully, our planetary defense radar. The Arecibo telescope, when it was active, would blast radar signals at near-Earth asteroids, signals so powerful they would, for a few moments, outshine the sun at that frequency. What if the wow signal was not for us? What if it was just an alien civilization's noise? What if we just happened to intercept the backsplash from their own, incredibly powerful planetary radar? Or the launch burn of an interstellar craft? Or a burst of energy from a vast planet-sized particle accelerator? This would explain its transient nature. The radar was pointed away. The ship left the system. The experiment ended. We were, for 72 seconds, in the spill of an alien's industrial activity, and then we were not. This is, in many ways, the most chilling theory of all. It would mean they are out there, they are advanced, they are powerful, and we are so completely and utterly irrelevant to them that they don't even know we heard them. For the rest of his life, Jerry Ehman, the man who found the signal, was haunted by this. He was a scientist, and he was dedicated to finding a natural explanation. He championed the comet theory for a time. Then, after it was disproven, he backed away, frustrated. He analyzed every scrap of data. He ran every known test. He, more than anyone, wanted to find the red herring. In his later years, he admitted his own frustration. He famously said, "We should have seen it again when we looked for it 50 times. Something suggests it was an Earth-source signal that was reflected. But we can't pin it down." This was his final, nagging doubt. The ultimate red herring, the one that, even 50 years later, researchers cannot entirely kill. The super-reflection theory. Could there have been, in 1977, a classified, high-altitude military experiment? A powerful, airborne transmitter, flying on the forbidden frequency, whose signal somehow bounced off a piece of space debris and into the telescope's beam, perfectly mimicking the 72-second bell curve of a celestial source? The mathematics of this are borderline fantasy. The original transmitter would have to be illegally powerful. The piece of debris would have to be unknown, untracked, and tumbling at the exact rotational speed to create that perfect 72-second bell curve. And it would have to have no Doppler shift, meaning it was somehow stationary relative to the telescope. It is a theory of 1,000-to-1 coincidences. It is so convoluted, so Rube Goldberg-esque, that it is far, far less likely than every other explanation. And yet, it refuses to die. Because the alternative is that it was real. Every investigation, every mundane theory has hit a wall. The comet, the satellite, the glitch, the reflection, every attempt to explain away the signal as human or natural has failed. They all fall apart under the simple, elegant, and infuriating facts. The signal was narrow-band. The signal was on the hydrogen line. The signal was 72 seconds long, a perfect match for the telescope's beam. The signal had no Doppler shift, meaning it was from a fixed, deep space location. And, as we now know, that location is home to a near-perfect twin of our own sun. The investigation has come full circle. The wow signal is not a whodunit. It is a whatdunit. We have exhausted all the mundane suspects, and we are left, after 50 years of searching, with the one suspect we had at the very beginning. The one that Jerry Ehman, in a moment of pure human shock, circled in red. The mystery box is, in a way, empty, but it is also, in another deeper way, full. The 72-second message, after a half-century of the most intense forensic investigation in scientific history, has resisted every single attempt at a mundane explanation. The file on this case is not closed. In fact, it has been blown wide open. The discovery of the Sun-like star, 2-mass 19,281,982 to 2,640,123, has transformed the wow signal from a historical curiosity into an active, high-priority manhunt. The search is no longer a blind scan of a crowded sky. It is a stakeout. We have a suspect. Today, the world's most powerful ears are no longer sweeping the heavens at random. They are returning, again and again, to that one, single, tantalizing point of light. The breakthrough. Listen Initiative, the most comprehensive SETI project in human history, is using the Green Bank Telescope in West Virginia, the largest fully steerable radio telescope on Earth, to stare directly at that star. They are listening with a sensitivity that Jerry Ehman and the Big Ear team could have only dreamed of. But they are facing a new 21st century problem. In 1977, an artificial signal meant a carrier wave, a simple, loud, narrowband tone, like a dial tone. It's the simplest, most obvious way to say hello. But would an advanced civilization still be using a dial tone? Our own technology has evolved. We no longer use loud, simple analog broadcasts. We have moved to digital. Our signals are compressed, complex, and spread spectrum. They are designed to look like noise, to pack more data in. What if the wow signal was just the call signal, the ringing, and the real message is a hyper-complex, data-packed stream that we, in 1977, would have mistaken for simple static? The new search is not just for a loud note. It is for a smart note. Computers are scanning that star, listening for the hidden fingerprints of mathematics, of language, of information buried deep inside the noise. We are no longer just listening for a shout. We are listening for a whisper of code. This new targeted search has also reignited the most dangerous debate in all of science. The debate over MIT, or messaging extraterrestrial intelligence. For 50 years, we have been a planet that only listens. The wow signal now begs the question, is it time to pick up the phone and talk? The controversy is fierce. On one side, scientists argue it is our duty. If they are pinging us, we should ping back. If we want to join a galactic conversation, we must first introduce ourselves. On the other side, a darker, more cautious view, famously championed by the late Stephen Hawking. He warned that if aliens do visit, the outcome would be much as when Columbus landed in America, which did not turn out well for the native inhabitants. He argued that a fledgling civilization like ours, screaming for attention in a dark, unknown forest, is a catastrophically bad idea. The wow signal is Exhibit A for both sides. If the signal was a lighthouse, or a scintillation event, they don't know we are here. A reply from us would be our first terrifying cry into the unknown. But if the signal was a sniper shot, a test ping, then they do know we are here. They are sitting in the dark, 1,800 light-years away, just listening, waiting to see if the prey moves. In that scenario, a reply is the single most dangerous thing humanity could ever do. For now, the consensus is to remain silent, to listen, to gather more data, to build a bigger ear. And that is exactly what we are doing. The ultimate legacy of the Big Ear Telescope is the Square Kilometre Array, or SKA. Under construction in South Africa and Australia, the SKA will be the largest, most sensitive radio telescope ever built. It will be a continent-spanning, digital ear so powerful it could detect an airport radar on a planet 50 light-years away. When the SKA comes online, the WOW signal star will be one of its first and most intensely studied targets. We will finally have a machine powerful enough to hear the faint, continuous broadcast, even without the cosmic magnifying glass of scintillation. We will be able to listen to that solar system with such clarity that any industrial noise, any accidental leakage, will be detectable. The mystery, one way or another, will likely be solved within our lifetime. The 72-second message, in the end, has become a multi-generational quest. It is a story that began with a sheet of fanfold paper in Ohio and will end with a supercomputer on the plains of South Africa. It has outlived its discoverer. Jerry Ehman passed away in 2009. He never lived to see the Gaia telescope identify the source star. He never got his answer. He died as he lived, as a man haunted by a perfect, unprovable anomaly. But his legacy is not one of failure. It is one of profound, accidental success. The WOW signal for 50 years has been the engine of our curiosity. It is the single greatest piece of evidence that the Fermi paradox, the great "where is everybody?" might have an answer. And that answer is, they are there. They are in the direction of Sagittarius. They are 1,800 light-years away. They live around a star just like ours. And once, on a warm August night in 1977, for 72 seconds, they were, either by accident or by design, impossibly magnificently loud. The signal has become a cosmic Rorschach test. What you see in those 6 characters, 6-5, says more about you than it does about the signal. Some see a statistical fluke. Some see a passing comet. Some see a secret military test. And some see a voice. We are back in the end where Jerry Ehman was. We are a civilization hunched over a piece of data that does not fit. A single anomalous clue that points to a conclusion so vast, so paradigm-shifting, that our minds instinctively try to find another, simpler explanation. But the data refuses to cooperate. The 72-second message is a ghost in the machine of the cosmos. It is the most profound, the most unsettling, and the most perfectly unsolved mystery of the modern age. It is the sound of a question hanging in the void. That single scribbled word in the margin of the printout, "Wow," was not just a note. It was a perfect, timeless, and utterly human response. It is the sound of a small, ape-like creature on a tiny, wet planet staring up into the great, silent darkness. And for one brief, heart-stopping moment, hearing that darkness stare back,